Hello all, I am Dr. Pravas. In today's class, we'll discuss about representation of intermediate code. Okay, so representation of intermediate code, or we can write here intermediate code or three address code we can write. Okay, we can also mention here three address code. Okay, so how to represent a three address code? How to represent a three address code? Generally, there are three methods. To represent the intermediate code, or we can write here three address code. Mainly, we'll tell what three address code. Okay. So how to represent a three address code. Generally, we have to use. There are three notations. Generally, there are three notations we have used to represent the three address code. Okay. The first one is quadruples notation. The second one is triples notation. The third one is intermediate triples notation. Okay. Generally, there are three methods to represent the three address code, or we can say intermediate code. Why we just tell it is as intermediate code or representation of intermediate code? Because by default, intermediate code generation is called as what? Three address code. Okay. Generally, we can represent intermediate code in four ways, or we can say linear form, or we can say tree form. Linear forms, tree forms like syntax tree, directed acyclic graph, or linear forms like postfix notation, three address code. But by default, representation of intermediate code means what? It is called as three address code. Okay. So this is, we can say, like representation of intermediate code, or we can say representation of three address code. Okay, because by default representation of intermediate code means what? Three address code. Okay, so generally there are three methods. First one is called as quadruples notation. Second one is called as triples notation. The third one is called as indirect triple. Sorry, this is not intermediate triple. This is indirect triples notation. Sorry, this is indirect triples notation. Okay, so one by one we'll see. Okay, first one question is given: represent the given statement, means this one as the statement, into the following notations like quadruples notation, triples notation, intermediate triples, indirect triples notation. Okay, so the first notation is called as quadruple notation. Quadruples notation. This is the first notation. Okay, so how to represent it? Before defining any notation, first we have to convert the given statement into three address code, because the given statement does not following any three address code, so we have to convert. Okay, so T1 equals to what? B star C. T2 equals to A plus T1, then X equals to T2. Now this is the three address code of the given statement. This is the three address code of the given statement. Now we have to convert quadruples notation. Let's see how to. Now we just construct a table, quadruple table. Okay, since it is quadruple, that means we have total 4 number of columns. We have total 4 number of columns there. Okay, let's see. The first one, this is the serial number, we can say. Sorry, this is not serial number. First one is called as operator. The second one is called as operand 1. Third one is called as operand 2. The fourth one is called as, we can say, result. Okay, the first one is called as operator. OP1 means operand 1. Operand 1. Okay. OP2 means operand 2. This is the result. Okay. So here in the given 3 address code, how many number of statements? 1, 2, 3. This is 1. This is 1. This is 2, 3. Means this is 1, 2, 3. First means the first statement. Second means the second statement. Third means the third statement. Okay. So now we'll stop. In the first statement, just see, in the first statement, here the number of operator. Sorry, here the operator means what? This is star. Simply write star. Then operand. Operand means what? B. Then second operand. The second operand means C. The result will store B star C in T1. So we'll write T1 as a result. Now we'll store the second statement. In the second statement, plus is the operator. So write plus is the operator. Then A is the operand 1. Then T1 is the operand 2. Then here result means T2. The result means T2. Okay. Then operator 3. Just say here there is no operator. Here there is no operator. Or we can say this is just like one unary operator, means plus. We can write here plus also. Because if there is no sign, means by default it is positive sign. By default it is positive sign. We can write plus. Here one operator, this is T2. There is no second operand. Sorry, this is one operand, because operand means T2. There is no second operand. So we can simply write as blank. Okay. Just leave this one operand because there is no operand. Then here result. The result is nothing but what? X. Result is nothing but X. We can also simply write as blank. Remember one thing, this is a blank symbol. Don't consider it is a negative symbol or minus symbol. This one is a but blank. We can just mention here. This is means what? Blank. We can write simply blank. Okay. So this is called as the quadruple notation. So this is called as quadruple notation. So similarly, we can write the second notation is called as triples notation. Triples notation. Triples, see, quadruple notation means there are 4 columns. Similarly, in triples notation means there are 3 number of columns. 3 number of columns. This is the first one. Second. Okay. First one is the operator. Operator. Then operand 1. Then operand 2. So here 3 statements. So we can write 3 statements. This is 1, 2, 3. Okay. So see. In the first statement, the operator is star. Operand is what? B, and operand, second operand is C. Okay, right. Then in the second case, the C. Here operator is a plus. First operand is A. Second operand is T2. Second operand is T1. But we can't write like this. We can't write like this. Because here we'll use the reference. Here T1. T1 means T1 is the result of the first one. T1 is the result of first one. So simply we can write here. Here means the results are, means operate means this line. We can see this line stores in, means B star C stores in where 1. So we can use the reference value 1 here. We can use the reference value 1 because here T1 is the reference of this T1. So that's why I write what 1 here. 1 means what? Here 1 means what? We can use like this. Okay, this one used from here. Okay, then here operator is plus, then T2. T2 we have used this T2 from where? The second one means second reference. We can use this reference as this one. So in this way, triples notation means we just use the reference pair. We use the reference number. We can. Okay, in this way we can store the 3 address code in triples notation. Okay, so third one, indirect triples notation. Indirect triples notation. It is very easy. Okay, I'm using this is 110, sorry 100, 101, 102. So this is 1, 2, 3. In this way we can write. That means what? Let's say 10 means when we'll access this 100, it will connect to the first reference. The first reference means it will access this way. It will access this one. When we'll access 101, that means it will connect to this, and these two will communicate to the second one. Similarly, when we'll access 102, 102 means what? 102 connect 3 and 3 connect to this one. This is called as indirect triplex notation. So all notations are very. So what is the difference between these 3 notations? Okay, now we'll see the difference. In the just say the quadruple notation. First we'll see the memory, about the memory. First we'll see the memory. As compared to quadruple, and we just compare quadruple and triples notation. We just compare the quadruple and triples notation. Quadruple notation generally takes more time, or extra memory as compared to triples, because triples notation generally uses 3 columns here, but quadruple notation generally uses here 4 columns. So memory means it generally takes extra memory. We can say extra memory. Okay. So triples notation means it generally takes less memory as compared to quadruple notation. Okay. So indirect triples notation, it uses what? It uses total 2 references, means 2 memory references to access any means statement. So it uses what? 2 memory reference can say. Okay. One more difference is, just say suppose movement means if we'll change the order. If we will change the order means, suppose I want to execute the first, means in this way 2, 1, 3. If I want to execute 2, 1, 3 in this way, there is no problem in quadruples notations. There is no problem in quadruples method. So we can execute 2 fast, then we can execute 1, then we can execute 3. It's not a problem. We can execute. Means there is no problem. If we change the order, if we change the order in quadruples notation, suppose I'll write 2 as here and 1 as here, there is no problem. There is no problem. So movement, there is no problem. We can say it's okay. But in case of triples notation, suppose if I'll change the order here, if I'll change the order, see, first reference is used in the second, and the second, this reference is used in third. So we cannot change the order here. We cannot change the order. If I'll change the means order, it means we may face some problem. We may face the problem because the first reference is used in operand 2. The second reference used in what? In the third statement, like this. So here movement we can't move. Here we cannot change the order here. We cannot change the order. In indirect triples notation, we can write anywhere. Means we can write here 1 0 1 and 2, and here we can write like this. Suppose here we can write 1 0 1, here we can write 1 0 0, here we can write 1 0 2. If I write 1 0 1, here 2 we can write, and 1 0 2 means 3. In this way we can change the order here. We can change the order. It's not a problem. So if we'll change the order in quadruples notation and indirect triples notation, there is no problem. But we cannot change the order in triples notation. Okay. So in this way we can construct the we can represent the 3 address code, means in quadruples notation, in triples notation, and indirect triples notation. Okay. This is the end of intermediate code generation. In the next class, we'll discuss about code optimization. Okay. Thanks for watching.